Hi guys, welcome back to Program with Sam, and today it's Java Lesson 1. So last time we set up the IDE and the JDK so that we're ready to create our Java programs. In this tutorial we will be looking at declaring variables, loops and conditional statements, naming conventions, access modifiers, and how you would do comments in your Java code. So first off, let's start with the primitive data types. And the first one that we're going to do is a byte. So a byte is just, it's 8 bits in size, and it can represent an integer in the value of minus 128 to 127. So if we say 127, that's fine, but for the purposes of this, we'll put 60 or something. You also have characters, or char, as they're commonly referred to. And this is 16 bits in size, and it can take a maximum value of 65,535 or a minimum value of 0. And the uses are to represent any Unicode character. So for instance, A. That is a Unicode character, and it will be represented there. The next one we're going to do is short. Now, the next sort of few coming, including short, are basically ways of doing integers. So this one is a 16-bit integer, is a short. And that means it can represent integers in the range of minus 32,768 to 32,768. I think that's wrong though. I think it should be 32,767. So we could do 32,000 exactly, and it would be able to do that. Then we have int, which is your regular int. If you've done any programming before in sort of like C, C++, you'll have come across ints before. In Java, it's stored as 32 bits, which I believe it is in other languages as well. And it can take any integer in the range of minus 2147483648 to 2147483647. So 10. Then you have long, which is essentially double the number of bits again. So this one is 64 bits, and that means it can take an even larger range of integer values. Aside from sort of like those integer-based primitives, we also have floating point numbers. So float is a single precision floating point number. And what that means is it's essentially a decimal number, something with a decimal point in it. A single precision is 32 bits, and we can represent any decimal number in between. Again, it's a huge range, so I will just put it in the screen as I have with the rest. So if we do 26.5, and then you have double. We have to specify f. Double, example double, and it's exactly what you would expect, whereas the float is 32 bits, the double is 64 bits, and that just means that you get a greater range of numbers that you can represent again. After that, there's only 2 more left to cover, and that is Boolean, which is a simple true or false value. So if we set it to true, so it's a true or false value, and you can use it for conditionals. You know, it's a binary thing. It either is or it isn't. It's a 0 or a 1. It's a true or a false. It's pretty simple to get your head around. Then they have null. Now, null is not exactly something we can declare. It's not necessarily a variable, but what we could do, for instance, is say, can we do Boolean test is equal to null? Actually, I can't remember. Can we do that? No. It's useful for objects. So for instance, if we do object test is equal to null. But essentially, it's similar to void. It's a Boolean primitive of sorts. And you'll use it for when maybe you don't necessarily have a value for something at that given time. Usually objects, as we've just proved. All of this code will be available on GitHub, and I will make sure to comment it all up with the actual definitions of what everything is. And I will write some example code to demonstrate it, which we will cut to now. Okay, we're back, folks, and I have made a small main function and sort of test run configuration for it. We had to make a quick constructor, but obviously since all the values are already set, we don't need to worry about filling anything in. In the main function, I basically have commented sort of like what each line of code is doing for you. And we'll just quickly nip through it now. So we create the primitive object so we can actually access all of the different variables we've declared. and we just write what the byte is. We write out the char, and then to prove that the char is actually stored as an integer value, I've also added it to another integer, and then we output that new integer, and comes out as like 105 or something, I believe, but we'll see in a minute. We do the same for the short, stating the max value and the min value, and for the int, the long, the float, and the double, so you can compare to see what I wrote up there in the comments, and you know, let me know if I've made a mistake or not. And then lastly, the boolean should output whether it's true or false or not. So if we give this a run, so here we then have the results. So it says what the byte is. The character was A. The new number is 102. The short is 32,000. And it gives you the min, or the max and the min. The integer, the max and the min. The long, the max and the min. The float, the max and the min. The double, the max and the min. And then the boolean was true. So that's sort of like an indication of how you can use these variables in your project, these different data types, and what they're good for. Obviously, the numerical ones you can add together. You can even add the chars to numerical ones because they're technically counted as integers. We'll just go over some of what this code is doing here then. So this is just creating an object of the primitives class. If you remember, we called this class primitives. Then this is the system.out.println. This is basically how we write to the console. If you've done any C or C++, you'll probably be familiar with printf. This is the Java equivalent for you. System.out.println. And then it's just a little bit of string inside there. And because of the way strings work in Java, we can concatenate with the plus sign. We'll be going into that later on in the series. So the next thing we're going to go over is modifiers, in particular for variables. There are three main types of modifiers that you can actually use for variables in your applications, and those are static, final, and volatile. But of those three, we're going to mostly be talking about static and final, because volatile is mostly used to solve sort of visibility problems of a variable, and that's particularly prevalent with sort of like multi-threading, which we're not going to get into in this series. So first up, let's do static variables. So we will declare a static integer, int, and we'll call it static int, and we'll say it's equal to 10,000 even. We'll also declare a final int, and we will call this final int, and that will be equal to 20,000. Now, then if we go into our primitives, we can do system.out.println, and we'll just do a couple of new lines just so that we're a bit further down the page, and then we will do system.out.println modify the static integer is bop, and we will insert the modifiers dot static int. Notice that the other one isn't coming up. In order to access the other one, you'd need an instantiated object of the modifiers class. We haven't instantiated an object like we did with primitives, but we can still access the static int. That's because that is universal to that class. Any objects created of the modifiers class will have access to that static int, but any objects that even aren't of that class will have access to the static int. Similarly, if we wanted to, we could increase the static int. So we could say .static int is, or we could change the value to say 50,000. And if we do that, we can then system.out.println static integer is now plus modifiers.static int. So now if we run this, we should now see at the very bottom, static integer was 10,000, the static integer is now 50,000. Okay, so the next thing is we're going to create a modifiers object. Modifiers m is equal to new modifiers. So now you should see we have access to the m.finalInt. So if we say system.out.println final integer is, and we plus the m.finalInt, it should come up with that. If we then try and say m.finalInt is equal to 1, it comes up with a compiler error. And this is because you can't assign a value to a final int. So it's to a final variable. Why is that useful? Well, for instance, if you need a sort of number that is completely unchangeable, it's immutable, this is the way to get around it. So you declare it as final, and then you cannot change it after that first initialization. But if we had left it there, we'd have to initialize it in the constructor. After that first initialization, that number cannot be changed, and that's why it's throwing up a compiler error. So what we'll do is we'll comment that out and say compiler error. As before, we can mention that other volatile ints. It's just sort of more useful when you're doing threading, multi-threading, that kind of thing. We're not going to touch on it here, but it's worth noting that that's how it's declared. Now we're going to move over and start looking at conditionals. So we're going to make a class called conditionals. In this class, we're going to be describing and defining the conditional statements available to you in Java. There are 4 main conditional statements available: if, else, else if, and switch. But obviously, they're not going to get very far without some actual logical conditions. And the logical conditions that you can use include greater than, less than, greater than or equal to, less than or equal to, equals to, and not equals to. So what I'm going to do is I'm going to create a couple of functions that test the conditional statements. Okay, so first we're going to have a look at if. Now, if statement compares the condition in here. So it literally reads if A is equal to B, and then it will execute what is in the block of code if this condition evaluates to true. So we've declared A is equal to 10 and B is equal to 5. Is it going to output A is equal to B? Is it going to output A is less than B? Or is it going to output A is greater than B? And if it does that, we've nested another conditional inside. So it then says if A is equal to 10, it will output A is equal to 10. Now this is a very trivial example, and it should be pretty obvious that it's going to go for this one and for this one. And if we check our results, it said A is greater than B and A is equal to 10, which is exactly what we were expecting. But that will lead us on to else. So now we have the test else. So an else statement always follows an if statement. So if A is equal to B, it outputs A is equal to B. Otherwise, if A is not equal to B, it does this block of code. And that's a way you can nest conditionals and make a huge tree of conditionals. But for the purposes of this, we're using the trivial example of A is equal to 10, B is equal to 5. So if they're equal, which we know they're not, it will execute this. Otherwise, they'll execute that. So we would expect it to say A does not equal B. So if we test that, A does not equal B. But what happens if we change it? What happens if we say B is equal to 10? We should then expect it to go A is equal to 10. Yes, that's correct. But what happens if we then say that condition is inverted? We should now expect it to do A does not equal B. There we go. So that's how the else section works. It's essentially whatever condition the if is checking for, the else will have code for the opposite. That's a good way of thinking about it, is if you want it to do one thing in this block of code, you can make it do something else if this condition is not met. So that will then take us on to else if. Okay, so now that we've written our test else if function, we're ready to actually demonstrate how it works. You start off with your if, and that's testing one condition. But let's say that condition fails, but you have more conditions you want to test for before you do your else statement. This is where the else if comes in. It allows you to essentially check for another condition before you move on to your else statement. And you can chain as many else ifs as you want, so long as, you know, they're going to have a chance at being true after the previous ones have taken place. So in this scenario, we've got A is equal to 10, B is equal to 5, and C is equal to 5. First off, it's going to check whether B is equal to A, and if it is, it will say B is equal to A. Then it's going to check if B is equal to C, and if it is, it will say B is equal to C. Otherwise, it means that it's not equal to either of them, so else B is not equal to anything. So if we run this code, it should say B is equal to C, and that's exactly what we get. Okay, the last conditional for us to look at is the switch. So a switch is a lot like a series of if and else if statements. You're just checking the condition of specifically one thing. So if we put A in this switch, in the case that A is equal to 5, it will output A is equal to 5. In the case that it's equal to 10, it will output A is equal to 10. And if it doesn't match any of the cases in here, it will say by default it's not equal to 5 or 10. So if we run that, we'll see A is equal to 10. But what happens if we remove the break from here? It says A is equal to 10 and A is not equal to 5 or 10. So what it's done is it's run through, it's found that, and then it's kept going for the default. What happens if we set A is equal to 5 and remove the break? It's then gone through every single item, every single case in the switch statement, which is not what you want. So it's important to remember to put those breaks in so that you don't get unexpected results when using a switch statement. That's it for conditionals at the moment. Okay, so now we're ready to have a look at loops in Java. So there are three main types of loop in Java, and that's the for loop, the while loop, and the do while loop. And they're each sort of slightly different, but for all intents and purposes, they're just going to iterate over a block of code. So we're going to start with the for loop. Now this is an iterative loop, which you can iterate over a set number of values, or you can also do a variant of it, which is the for each loop, declared in a similar way, and that iterates over a collection of objects. But we'll come to that later when we get into more of the course and the nitty-gritty bits of Java. For now, we're just going to do a simple iterative loop for a set number of values. So we're going to start by declaring a variable. Int I is sort of like the common thing, and this is going to act as your counter. And so you say int I is equal to 0. And if we say I is less than 10, so that means it's going to iterate 10 times, because obviously I is going to start at 0. So it's going to iterate 10 times. And we just do an I++, which means after each iteration of the loop, it will increment I and run the loop again. Increment I, and at the start of each increment, it's going to test the condition. It's going to test whether I is less than 10. And if it is, it will run. If it's not, that's it, we're done. So what we want to do is we want to say system.out.println, and to prove that it's going to run for 10 iterations, we're going to do iteration number bop, and then plus I plus 1. So that's going to mean that it's going to go, it should count 1 to 10. Then if we do l.forLoopDemo and we run it, we're running the wrong thing. We need to add a application test loops. Main class is loops. Run it. There we go. Iteration number 10. So it iterates over the loop 1 to 10. If you wanted to change that and say 15, it should now run for 15 attempts. There you go. So, the next one is the while loop. Now, while loops require a condition to be true. So if we set up a dummy boolean, call it flag is equal to true for now, and we can say while flag. Now that essentially means that's shorthand for saying while flag is equal to true. Okay? But we'll just say while flag. If then we say int I is equal to 5, or no, e is equal to 0, and we'll just do I++. If I equals 5, which is using the conditionals that we've just seen, we then say flag is equal to false. So what this is going to do is, while flag is true, it's going to keep iterating indefinitely through that loop. indefinitely. Like if we removed this bit here, this conditional, to change it, nothing would change. Like it would just constantly be incrementing I, and you know your application is probably going to hang. So what we can do then is we can do system.out.println iteration number and then plus I. So this is going to count all the iterations through the loop, and it should get, I think, to 4. Let me think. So it's going to do 1, 2, 3, 4, 5. Oh no, it should get to 5. Should get to 5. Okay, so that's the wrong test. We want to do while loop demo. There we go. So yeah, it's iterated 5 times through the loop. And it's gone through, and then when it gets to I is equal to 5, it sets the flag equal to false. So when it comes back up, it says while flag is true, but it's not true anymore because we set it to false. So it resumes with whatever code comes afterwards. In this case, it just stops. Now, the difference between that and a do while loop is that the evaluation in a while loop happens at the start. The evaluation of a do while loop, do this while that, and we say flag. So while flag is equal to true, it will do it. And if we just copy and paste that same code, we would expect the same result. So if we now run it, we would expect exactly the same result as before. Boom. But what happens now if we change this to false? So it's false to begin with. In a while loop, it just wouldn't run. Nothing would happen because it would evaluate first. But in a do while loop, you'll see it will run at least once. And that's the important part to remember between a while and a do while loop, is a do while loop is guaranteed to run at least once. So you're guaranteed at least one iteration of that loop. Okay, the next thing we're going to be looking at is the naming convention in Java. Obviously, you may have noticed by this point that I've adhered to a semi-strict naming system of variables and functions in the classes that we've been making. So function names will be... They will start with a lowercase, essentially. They will have a lowercase, and they should contain a verb realistically. So if we have sort of like find error, that is one function, and that's how you would do a function. Similarly, variables, which you would tend to put at the start, you would have start with a lowercase letter. So we would go for all, and then any subsequent words would be capital. And you don't have to worry about a verb for a variable, obviously. Class names, as we can see, should have a capital letter. And I think that's just a given, to be honest. Then when it comes to constants, so for example, your final int, let's say it was max height, that would be all caps for your constants in your application. So the last thing to cover is package names. So you'll see all of the packages over here are, can I zoom in? No. Are in lowercase. And words should be separated with dots, which you can do by just creating a new package and then do scheme. And then that makes naming.scheme, and that's the package. So then if we created a new package, a new class in there and called it test package, you would then have naming.scheme. And that is how you would name packages. So that is the naming system in Java, generally speaking. Obviously, you can use your own, but most of the time, most of the Java code you see will look similar to this. So the next thing that we're going to be going over are modifiers, in particular access modifiers for variables and methods. So for variables and methods, there are 4 access modifiers available in Java, and those are default, private, protected, and public. Now, default, the scope is then limited to the package only, meaning that only classes in the same package can access it, and that's done by just not having anything. So if I remove that, that is a default modifier. It's got nothing there. That's what it is. The next one is private. and private just means that it's local to just that class. Now, you may be wondering, well, what if you have this private variable for security purposes? You don't want other classes to be able to actually actively modify the variable because you want to make it more secure. How do you then modify that variable? You do that through what they're called getters and setters, which are simple functions that just update the variable with given values. The next one is protected. Protected variables and functions are only accessible by other classes in the same package and any subclasses of those classes. And then public can be accessed from anywhere. So if we made this public and then just static for the sake of being able to see it, and we went into primitives, we'd then be able to go naming dot, and we can see all airports there because it's public. But if we turned it into, say, private, we would not be able to see it anymore. And it's gone. So that's the difference there. So the last thing for us to go over today then is comments in Java. You've probably seen some of the comments already just in code screenshots or in the code that we've been writing thus far. There are three types of comments. You've got your single line comment, your multi-line comment, and your Java comments, which are a bit different to the other two. So single line comments you've probably come across before in stuff like C and C++. If you haven't, there are two ways of doing it. You can either do it like this, which is just the double slash and it will comment out the line, or you can do it like this. You can use a multi-line but just do it in a singular line. So in that case it would be just like that. And you say single line. The benefit of doing it with the stars is that you can then have a multi-line comment. So you can comment out entire chunks of code that maybe don't work or you no longer want in the testing. There are uses for the multi-line comment. If you want to make a big block of comment before you do something because it's sort of like a bit of crap code or something, and you want to make sure that it's known to whoever's reading it that it is crap, that's a good way of doing it. Which brings us on to the last comment, which is the Java comment. Now, Java comments are useful because they allow you to essentially create web pages, and the Java doc then gets put into its own web page, essentially. And that allows you to essentially generate documentation for your programs, which you can then host online, and people can then see how all of the functions are working, what arguments they take. So it's particularly useful if potentially people can program their own things for your application. You can then have your Java doc explaining how they interact with your application using their code. So you would define the function in this space, and you'd sort of like say what the parameters are, what they're supposed to be, and what it should return. And then we'll go into generating Java docs at some other point in the series. But that is all for this episode now. Next time, we'll be looking at objects for primitives, strings and string manipulation, array lists versus arrays, and input and output to Java programs. If you could follow me on Twitter at ProgramSamBlog, or follow the blog itself at programwithsam.co.blog, that would be much appreciated. And I'll see you all in the next one.